Alright, then let's start defining the rules of the database and the storage. So open the Firebase console in your browser, then open the real-time database and click on rules tab. Now from here I can just remove these two comment lines because they are not relevant anymore, as I have already changed the rules, so I can just get rid of them. Now as of now we have write as true as well as the read as true, which means all the read and write requests coming to the real-time database will be processed and approved, and even the requests which are coming from unauthorized users or unregistered users will be processed and approved by the real-time database, because we have allowed all the reads and all the writes on the database. So in a way we can say the database is in a total open condition, like anyone can access it. Anyone who is having the reference to our database can access it. So let's see what we can do to change this. Let me just remove these two lines and let's start with registered users, because in the database we have defined registered users as the root node. Then under the registered users we have different data items which are saved by the name of the UID or the user ID of the respective users. So let's begin with registered users. It has to be within double quotes, then semicolon, then open the bracket. Since this is not a general video talking about the security rules, I'm not going to go into too much detail how we have to write the security rules for database for different cases, but instead I'll just focus on the cases that we need to work on in our project. Then dot read, and this read also has to be within double quotes, then semicolon, then within double quotes we have to write auth.uid. Now this dot read describes if and when data is allowed to be read by users, and we have to keep in mind that dot read and dot write rules cascade. And the real-time database security rules include built-in variables and functions that allow you to refer to other paths, server-side timestamps, authentication information, and more. And the primary building block of real-time database security rules is the condition. A condition is a Boolean expression that determines whether a particular operation should be allowed or denied. And if we are working with a very basic application, then the basic rules like using true and false literals as conditions, they are going to work perfectly well. But since we are now going to define a complex rule for our database, which means we have to come up with some complex conditions that can check user authentication, validate incoming data. And one of the most common security rule patterns is controlling access based on the user's authentication state. Like for example, your app may want to allow only signed in users to write data, and this is exactly what we intend to do. We want only the signed in users to access the database, and the data should be their own data. They should not be able to access the data of other users. In Firebase, the real-time database allows us to control data access on a per user basis using conditions, which means once a user authenticates, the auth variable in our real-time database security rules will be populated with the user's information. Now this information includes their unique identifier, which is the UID. Now let's see how we can obtain the UID of the user and check whether it is null or not. So for that, just write auth.uid not equals null. Then I'm going to do the same for the write. Now this condition means that if the UID of the user is not null, only then we are going to allow the read and the write on the database. We can also write auth is not equal to null. Now that condition will mean that we are allowing the access to the database if the user has been authenticated. But since I have written auth.uid should not be null, which means the user ID of the user should not be null. So both of them are a little different, but they work in the same way. Now let's publish this rule. Alright, I made a mistake. This entire condition should be inside double quotes. So just remove it from the end of UID and add it to the end of null. Then do the same with the right rule. Alright, then publish it, and let's try to simulate the rules that we have published, which means we can like run some test conditions to check how the database is going to respond to different requests coming from different users for different data items. So let's see how we can simulate them or how we can work around them. Alright, the simulation type is read and then location. In the location, let's say / registered users, since our first node is registered users. Then / 123. This 123 will represent one UID, which means let's say there is some user who has UID as 123, and let's say this user is authenticated. Alright, then let's say there's another user with UID 456 which is trying to access the data which corresponds to the user with UID 123. So this is a classic example in which a user is trying to access the data of another user. Let's see if it will be allowed or not. Let's just run it. And you can see that the simulated read is allowed, because according to the rules that we have written, everything is perfectly fine. The user is authenticated, the user is having a UID which is not null, and that user is trying to access the data in the database, which is perfectly fine. So the user is allowed the access, but we want to restrict the user to access its own data only. And if you try to run this for update simulation type, you will get the similar response, that is the update will also be allowed, since the right rule also specifies that the user should be having a UID which is not null. So according to the rule, the user will be allowed access to the database. Now what we want to do is to check whether a user is trying to access its own data or not. If the user is not trying to access its own data, then we can reject those read or write requests. So for that, let's get into the condition and let's begin with read rule. So just add ampersand then $UID. Now this dollar variable is like a wildcard, and it can capture and store the value of that key for use inside rules conditions. Like in simple word, when a user is trying to access the database, then because of this wildcard dollar, this will mean, or you can say this $UID will be replaced by the user ID of the user. Then we have to write equals 3 times, because this is how we compare equality in real-time database. auth.uid, which means basically we are just obtaining the user ID of the currently logged in user. Now this dollar variable is used to capture path segments, or we can say we can capture portions of the path for a read or write by declaring this capture variable or the $wildcard. Then I'm going to do the same for the write rule. Alright, now we need to enclose this read and write rule within another structure or another path. Let's say we want to check inside the registered users, the name of the node, which is the UID of the user, equals to the UID of the user which is trying to access the data or not. So for that, I'll just simply write $UID, then I'll open a curly braces, and after we are finished with the write rule, just add one close curly braces. Now this means that inside the registered users, we are checking the UID or the name or the path name of child node of registered user, and then we are checking whether this UID is the same UID of the user which is trying to access this data or not. I don't know if you're getting it or not, but I will show you with an example what I mean by this. Let's just publish this. Alright, I'm getting error again. Just after the quotes, add one semicolon and publish it. Alright, now let's have some fun with the rules. So let it be the same, registered users 1, 2, 3, let it be the same, and let the simulation type be read, and let's keep the UID as 456, and let the user be authenticated as well, and let's just run it. And the read has been denied. Let's see the details, and it's saying the read has been denied because of the rule that has been specified at the line number 5, and that is the rule where we are checking whether the UID of the currently logged in user equals to the UID which is there in the path name. If both are same or not, we are checking in the line number 5, and it's clearly not the same. In the location, you can see we have registered users /123, and this 123 is actually corresponds to $UID. So as I told you that this dollar variable is used to capture path segments. So here the dollar has captured the path segment which corresponds to the UID of the user which is creating the data. And here in our case it is 123. And then by using auth.uid, we are obtaining the UID of the currently logged in user, which we have specified as 456, and clearly they both are not matching. So the read has been denied. Now let's just change this UID to 123. And run. And the simulation has been allowed, the read has been allowed, because now the user which is having the UID 123 is trying to access the data which belongs to the user 123. So in simple word, the user is trying to access its own data, so it has been allowed. I hope you're getting how we use this $wildcard. It is just saving the value of the key which is there after registered users, and then that value is used to compare with the UID that is obtained from authentication. Alright, let's say the user is not authenticated, and now let's run, and the simulation read has been denied because the user is not authenticated, which means the user is not having any user ID, so such a read is not allowed. Alright, now let's check for update rule, that is the right rule. And you can see that the update is also allowed. So in this way we have defined the rules for the real-time database which allows one user to access its own data only. The user cannot access the data of any other user, as well as a user has to be a registered user on the app to be able to access the database. Alright, now let's do the same for the storage. So just open storage and then open the rules. And for now we are allowing all the read and write on all the path and for any extension. So let's begin with our specific location. So I'll just write display pics because that is how we are saving our display pics in the storage. So I'll just write display pics /123, and let's say the user is not authenticated, and let's just run it. And you can see that the simulated read is allowed, which means anyone or any user, whether the user is a registered user on the app or not, anyone can access the data which is there in the storage. Now the location is display pics 123, which means under the display pics folder we are referring to the user which has the UID 123, and the user which is trying to access the data has UID 456, and the user is authenticated as well. Now let's try to run, and you can see that still the read is allowed because we are allowing all the reads, and the read and write rules have cascading effect. Now let's change our path, the path which will be checked by the security rules. So after match, let's say /display pics and then / all paths equals $, and allow read write if request.auth is not null. which means we are going to allow the read and write inside the display pics directory only if the request which is coming from the app belongs to an authenticated user. If the authentication is null, which means the user is null, we are not going to allow the read or write. Let's publish it. Let's publish the rules and let everything be the same, and let's just make the user unauthenticated, or let's say the user is not authenticated, and then run. And you can see that the simulated read is denied. The user cannot access the display pic directory since the user is not authenticated. Alright, let's make the user authenticated and let the UID of the user be 456, which means a user is trying to access the data of another user and the user is authenticated, which means even though the user is authenticated, it is trying to access the data which belongs to another user. So let's run, and the simulated read is allowed here also, because we are just checking whether a user is authenticated or not, whether a request is coming from authenticated user or not. So because of that, the read is allowed. So let's change our path for matching. Let's say after display pics, we want to create another directory with the name of the user ID. So that means we will have one display pics as the root folder. Under the display pics folder, we will have different folders for different users, and all the folders will have the name as the UID of the respective users. Then inside that folder, we are going to save the picture. So by writing like this, user ID within curly braces, we can compare the user ID of the user which is making the request with the UID in the path segment. Anyways, I don't know if you are getting it. Let's just continue with the rule. And here, after checking whether a request is from authenticated user, just add ampersand, that is for and then request.auth.uid, which means we are obtaining the UID of the user which is making the request, and then we will match this UID with the user ID which we have in the path segment, which means we are just checking whether a user is trying to access the folder which belongs to that user or not, or we can say we are just checking if the user is trying to access its own data or not. Let's publish it. Alright, I just missed to write one closing bracket after user ID. Now let's publish it. Let's say a user is not authenticated and trying to access the data, and the simulated read is denied. It's very obvious. I don't even have to explain this. Then after that, let's say the location is display pics /123/pic.jpg. If you do not understand the path that we are using, let me just write it in comment. So the files are going to look like this: display pics /UID of the user /pic.jpg. So for our example, let's say the pic belongs to the user ID 123. So it will be display pics /123/pic.jpg, and here 123 will be the user ID or the UID of the user. So we just have to check whether the request is coming from the user which has UID 123 or not. If the user has UID 123, then we can allow such read and write access. And let's say the user is having the UID 456 and is trying to read the data which belongs to the user 123, and simulated read is denied, which means the user cannot access the data of another user. It is because this user ID should be equal to the user ID of the user, which means the UID that we have in the path should match with the UID of the user who is making the request. So let's say the UID of the user is 123, and in the path also we have 123, which means the user is trying to access its own data. So let's run, and the simulated read is allowed this time, which means the user is trying to access its own data, which is perfectly fine, and we are allowing that. So that's all we have to do for setting up the security rule in storage and real-time database. Since this video is not about teaching or talking about the database rules in detail, so I'm not going to go into too much detail about them. If you want to learn more about the database rules, you can let me know in the comment section, and I'll make one video about setting up the rules in database as well as the Firebase storage, and there we can talk about all the different cases that we might come across, and we can talk about some general security rules that we should implement in our projects. But that is for a different day. For our app, for the project that we are building, this much rule is sufficient. So let's get back to our app, and let's create one new user, and then let's try to delete the user, and let's see if we are able to delete the user object as well as the data which is related to the user from the database as well as from the storage. Let's see. So I have logged in. Alright, I have the data as well as one photo in the storage, and let's delete. Enter the password, authenticate, done, then delete user, continue, and there is no toast. I don't know why it happens sometimes. I don't get any toast message in the emulator, but anyways, I'll just open the Firebase console and check whether the data is there or not. Alright, so in the storage the photograph is there, it has not been deleted. Let's see in the real-time database, and there also we have the data present. And let's open authentication tab, and let's see if the user is present or not. So the user has been deleted, but the data which is related to the user is still present. Now to start getting toast again, just close your virtual device and then click on this arrow next to the name of your device, and then select AVD manager. From here, under the actions, click on this arrow and then click on wipe data. This will wipe your entire data, and it's like creating a new device. It will wipe everything that you have on the device, and in most of the cases, by just making the device new, the problems are solved. So anyways, after that I'll just start my device once again. Now while the device is booting, let's talk about why we are not able to delete the data which is related to the user. And it is very obvious, it is very simple, very logical. We are deleting the user object first, and then we are deleting the data which is related to the user. Now if you think, after the user is deleted, can we even access the data which is present in the real-time database or in the Firebase storage? Because there we have set the security rule as any access coming to the database or the storage should be from a authenticated user, or it should be a valid user. And since we are already deleting the user, how can the user be an authenticated user? So this is the exact reason why all the request which is made to the database and the storage is getting rejected. So to solve this problem, we have to make some changes in our code. We have to change the logic. We have to delete the data which is related to the user first, and then after deleting the data, we can finally delete the user object from the Firebase. So if you allow all the read and write to the database and the storage, even though you will be able to let the user delete the profile first and then the data of the user, but doing so you are making your database and the storage vulnerable. Any hacker or anyone who has the reference to your database or your storage can access all the data, can read it, or can even delete it. So we have to set up the database rules to make it more secure, so that a user is able to access the data only if the user is authenticated. That is, the user is having a valid user ID or the UID, and the user is trying to access its own data. So this is exactly why I chose to do it like this, just to make you understand. And to change the order of the delete action, it's very simple. We will call the delete user data method first, and then after that we will call the delete user method. So let's just get into the coding. And under the show alert dialog, we are calling the delete user function when the positive button is clicked, which means when the user clicks on continue button, only then we are calling the delete user method. And then delete user method deletes the user, and when the deletion of the user is successful, then delete user data method is called. So here under the onClick method for the positive button, which is the continue button, let's call delete user data method instead of delete user method, so that delete user data method is called first and the data of the user is deleted first. And here we will have to pass the Firebase user variable. Now let's scroll to the delete user data method. So in the method also we have to set the parameter. Alright, then here after we have deleted the picture and the real-time database, we can delete the user. I hope you are getting it. Anyways, if you are not getting it, just follow with the video, you will catch up with the logic. And also, before deleting the profile picture, we will have to check whether the user has uploaded any profile picture or not. In case the user has not uploaded any profile picture, we cannot delete anything. So I'll just check whether there is any photo URL present for the user or not. If there is any photo URL present, that means the user has uploaded a profile picture. So in case the user has uploaded a profile picture, then we can go ahead and delete that profile picture. So I'll just cut this entire portion which we have written for deleting the user's profile picture, and I'll paste it inside the if case. Now for deleting the user, let's just get inside the onSuccess method. That is, after deleting the data of the user, we can just delete the user finally. So we can just call the delete user method from here. And here we don't have to pass the Firebase user variable. So I'll just remove the parameter and let me add the comment. And also, before we forget, let's just delete this delete user data method under delete user, because we have changed the ordering of the method. The delete user data method will be called first, and on successful execution of the method, it will call delete user. Alright, and also if you remember, while specifying the rule for the storage, we have specified the directory as display pics /, then the UID of the user, and then /pic.jpg. So we will have to make some changes in our app also, so that we are saving the picture of the user in this format, because we have to change the format of the directory for the profile pictures. So just open UploadProfilePicActivity and scroll to this method UploadPic. Now here we are saving the picture inside display pics directory with the name as the UID of the user, and then dot. After dot we are having the extension of the file. So we can make some changes here. So here I'll just write / display pic dot. So it's very simple. It will be display pics as the root directory. Under that we will have one directory as the UID of the user, and within that UID the file will be uploaded as display pic dot whatever is the extension. Let's say the extension is JPG, so the file will be display pic dot JPG. Like for example, it will be display pics / 123 / display pic dot JPG. It will be like this. So let's just run the app now. And let me quickly register, as we have deleted all the user's profile before. Alright, registration is complete. Then I'll quickly upload one profile picture. Alright, then let's open the console, the Firebase console. And here, this second one, the second node, this belongs to the user which we have already deleted. So I'll just delete this node. The first node is for the user that we have created just now. Now coming to the storage, we have the display pics as the root folder. Coming inside it, we have one folder with the name as the UID, which means the other photo belongs to the user which we have already deleted. So I'll just delete that. Now opening the folder, we have display pic dot JPG, and this is the picture which we have uploaded just now. So the real-time database has one set of data or one node, and authentication has one user object, as well as the storage has one profile picture, and they all belong to just one user that we have created just now. So I'll try to delete the user now and see if we are able to delete all the data which is related to the user as well as the user object. So I'll just delete it, authenticate, then continue. And we have started getting the toast messages once again, and it says that the user has been deleted. So let's open the console and check. Let me refresh, and you can see in the real-time database we have no data. In the authentication part also you can see that there is no user present. All the users have been deleted. And similarly, if we open the storage, and there also we have no data. So which means the user has been successfully deleted with all the data which is related to the user, and this is exactly what we wanted. And if you want, I'll just write a comment for the database rules. Alright, so this completes all the major portion of this app. Now in the next part we will just see how we can add pull to refresh or scroll to refresh.